So give a property of magnesium. Magnesium is a metal, so there's lots of properties you can state here. So you could say it's shiny, it's a malleable material, it would have a high melting point or boiling point, whichever one you want to put down. So high melting point, high boiling point. Be a good conductor. Of electricity. So you need one, any one of those will do. Which element is the same group of the periodic table? So remember, groups in the periodic table go up and down. So if you have a look in your periodic table, you will see that strontium is in the same group as magnesium is. Magnesium's got 12 electrons. Complete the electron arrangement. So they started us off with 2, 8. 2 and 8 gives us 10. So we're 2 short, so it's going to be 2, 8, 2. The electron configuration of chlorine is 287. Explain how the electron configuration is linked to its position in its period, in the periodic table. So here, the way this works is each energy level is the period in the periodic table. So because the last energy level being used is the third one, this means it's in the third period. So the way I would explain that for 2 marks, I would say that chlorine has 3 energy levels. So it is in period 3. And there'll be 1 mark for each of those responses. Okay? Next one, bit of a calculation here. It's an empirical formula calculation. So the first thing I'm going to do is put down the 2 elements involved and the mass that we have. So this is the mass we have of each substance. So I've got 1.20 grams of magnesium and I've got 3.55 grams of chlorine. Next job is write down the MR, the relative atomic mass. So we've got 24 for magnesium and I've got 35.5. Then what I need to do is work out the number of moles. Remember, moles equals the mass divided by the MR, which is why we've written it down this way. So if I just do that on my calculator, it's 1.2 divided by 24. So let's just make sure we write down here that that's what we're doing. So 1.2 divided by 24 is 0.05. And on this side, we've got 3.55 divided by 35.5. So 3.55 divided by 35.5 is 0.1. And then the final stage is divide by the smallest. So smallest number here is 0.05. Divided by itself is going to be 1. And 0.1 divided by 0.05 is going to be 2. So therefore, my empirical formula would be Mg. Mg gets number 1, and chlorine gets number 2. So Mg is just Mg, and then Cl2. Now they're giving you 3 marks for this question. So you would get a mark in here for setting out that you're going to do that. You then get a mark in here for the ratio, and you get a final mark for writing down it's a 1:2 ratio. Moving on, this one here is looking at types of bonding. So we've got ionic bonding and covalent bonding. It says describe the differences in these two. So what we need to remember for ionic bonding is it is the oppositely charged ions that hold this together. So underneath here, I'm going to put down the ionic bonding oppositely charged ions are held together by electrostatic attractions. Okay, why have those ions been formed? That is because metal atoms lose electrons to form positive ions. Non-metal atoms gain electrons to form negative ions. If we now do the same for covalent, so covalent, as you can see in the picture here, they don't form ions, but what they do is they overlap their energy levels and they share a pair of electrons. So covalent bonding, the atoms share a pair of electrons. Okay, so in terms of marks in there, you're going to say opposite charged ions are held together by electrostatic attractions. You're going to say, in fact, it's probably just going to be one mark there. You're then going to say metals do that to form positive ions, non-metals do that, and a covalent bond is sharing a pair of electrons.